I'll seek you out, flay you alive.
Hey guys, Pogo here. I have something pretty cool to show you guys today. I've been working on a project for the last few months. It's a new programming language, and I'm really proud of it. So the idea for this project began when I was working on programming. I was working on a project in Java, and I thought it's kind of strange that programs are written for computers with such a strict syntax and all of the special words that the computer uses, because it's humans that write it and maintain it and edit it and change it and review it. All the computers do is run it. So it would make a lot more sense for the code to be written in, say English, and then the computer just be able to understand it. It would be a lot easier for people to get started, to learn how to program, to actually write the programs, and then to look back to find bugs or anything like that. So I decided that I wanted to take on this task. I wanted to try to make a programming language that would look more like regular English instead of, computer programming language. And I think that I've accomplished something pretty good so far. Remember, this is currently in alpha, so it's a new thing, early stages, still a bit buggy, not a ton of features, but it does work very well, and I can show you a demonstration. Now, how did I go about this task? I thought about it for a while, trying to think of different ways, and I got the answer when I was playing the game 20 Questions. That's the game where you answer 20 questions, and then an AI is able to guess what you're thinking of. The AI is really good. They claim 80% correct. They can guess if you are given 20 questions. If they're able to ask 25 questions, then they're 98% accurate in guessing what you're thinking of. So I wanted to take an idea sort of like this, where it almost has a conversation. It asks you a bunch of questions and then renders a verdict, and it's really accurate. So I looked into how exactly 20 questions works, and it turns out that the AI, the artificial intelligence, is structured a lot like a brain. There are little bunches of data that are together, and they're connected to each other by synapses, just like a brain. Now, as you answer questions, the AI travels through the different synapses and looks at all of its results, all of its possibilities, and then in the end it's able to figure out what you're guessing. The really cool thing about this is, let's say that you're thinking of a purse, and the question comes up, is it larger than a loaf of bread? Let's say that you think that purses are generally smaller than a loaf of bread, but the system thinks for some reason that it's larger. When you get to the end, after the 20 questions, the system will probably still be able to guess, even though you answered that question different than it thought. It will then tell you, you answered this one question strangely, do you think that I'm wrong? And if you say, yes, purses are generally smaller than a loaf of bread, then the system will take that into account. And if enough people agree with you, then that will become fact. So the system can learn from its mistakes with the help of other humans. You don't have to sit there programming in tons of different attributes and data for all of the different nouns that it could guess. All you have to do is play the game and correct the system when it gets something wrong. So I took these ideas and I put them into a language that operates somewhat like 20 questions. It works using the English language, and everything that you see written in the language would be a grammatically correct and completely valid English sentence that someone could say out loud, and it would make a lot of sense. To aid with the comparison, I'm going to open up Eclipse here, and I'm going to have Java open, and we're going to go through a couple of examples of programs. We're going to see how they would be written in Java, and then we're going to see how they would be written in SympLang, the simple programming language, spelled S-Y-M-P-L-A-N-G. So that's the name of the project. Let's take a look with the first thing. Of course, whenever you look at a programming language, you always start with hello world, just printing out hello world. I have set up the class declaration and the main method, and I could just go ahead and write system.out.println hello world. And if I go ahead and run this, whoops, it will say, hello world. Great. Now, here's the problem with this. Imagine if you're reading this code out loud. Public class demo, public static void main string array args, system.out.println hello world. And I left out a lot of the, curly braces and parentheses. I called this thing an array, although they're technically square brackets, and all that stuff. So when I say that out loud, it's really not intuitive, and you would have to think about it to understand what it does. There's a lot of boilerplate stuff on here. You don't need to have a class and main method declaration if all you're doing is printing out hello world. So Java, I would say Java probably loses this round, but let's see how SympLang squares up to this. So I'm going to go ahead and open up the IDE. This is really, really basic. At version 1.0.7 alpha, so I have been working on it recently, but this is a very, very simple IDE, and the language is in its earlier stages. But I'm going to go ahead and create a new project, and you'll see here, this is the code area where you type in your code, and then down here is the console where the output will go. So we can try this out, we can type in some code, and then we can look at the output. And then up here you can save the code, run the code, and then the manual, which is still a work in progress. So I'm not going to look at that right now. So to work in SympLang, you simply tell the computer what you want it to do in English. So in this case, if I wanted to print out hello world, I could just say print hello world. That's a valid line in SympLang. All I'm doing is I'm telling it to print hello world, and it will be able to figure out that I'm saying print, and it'll say print, oh, that's the command to write something to the console, and then hello world is the message that I want. No parentheses, no curly braces, nothing. So if I wanted to say this program out loud, I would say print hello world. That makes complete sense. I don't think you could change anything to make it any more clear. Let's go ahead and run it. So I'm going to hit run, and you'll see down there the console says hello world. So it's able to take the message print hello world, and it works. Now that's not terribly impressive because that's essentially like Python. Python is almost like this, but with a lowercase p and then quotation marks around hello world and a semicolon. So that would be really easy to make in a language. You just notice the word print and then echo out everything after that. So we don't, that's not really impressive. But one of the cool things about SympLang, the way that it kind of works like a brain, is it can associate different words with each other, and it can also associate words as synonyms. So I have the word print, but I could use the word write or echo. So if I say write, for example, and I hit run, it will print out hello world. There, of course, there wasn't a difference there, but it did run a second time and print out hello world. So any word that would possibly mean writing, write, print, echo, display, show, will work because the system knows, or SympLang knows, that they're all synonyms, and it can kind of match them together. It's kind of like how PHP has echo and print, I believe. Now let's take a look at a better example, because hello world is boring, and it's also not terribly impressive. So let's say that we want to write out the numbers from 1 to 5. We'll go ahead and say for int I equals 1, I is less than or equal to 5, I plus plus, or then we'll just print out I. And if I go ahead and run this, you'll see it says 1, 2, 3, 4, 5. Let's read this out loud. For int I equals 1, I is less than or equal to 5, I plus plus, system.out.println I. Again, not very, not very easy to understand. If someone said that out loud, you'd have to stop and think about it. This is the kind of thing that I'm trying to avoid with SympLang. This is great for computers. It's very structured. You got your semicolons, your different operations, your curly braces, but SympLang is made for English. So let's take a look and see what SympLang will do about this. We'll go ahead and say write the numbers from 1 to 5 inclusive. So that will simply take the numbers from 1 to 5 inclusive, so including 1 and 5, and write them out. So let's go ahead and run that. So I hit run, takes a second to compile and figure everything out, but then you get there and it does say 1, 2, 3, 4, 5, the exact same thing with one line, and you couldn't really be too much more specific if you were saying it out loud. So what happens here? Essentially, it sees the word write, and it knows that you're trying to write something. When it sees something like the numbers from 1 to 5, it can figure out that you're talking about a sequence. You know, if you had some kind of a list or an array, and we're going to look at that, then it would go through all those numbers. But when I say the numbers from 1 to 5, it can figure out that it is the, sequence of numbers 1, 2, 3, 4, 5. And then inclusive, I'm just making sure that it knows to include 1 and 5. So it's able to figure out to include the upper and lower bounds, which are 5 and 1. So again, that also works, and it's a lot simpler, of course, than Java. Here's something really cool about SympLang. Let's say that we want to write 1 through 5, but the actual words. It would say O-N-E, T-W-O, etc., all the actual words. If we wanted to do that in Java, we would probably do something like string array nums equals new string array, and then it would have 1, 2, 3, 4, 5. And then we would just say for string num and nums print out num. Now, of course, you could just have 5 system.out.printlns in a row, but this would also be another way to do it. And I think that's better. So you have your array of your values, and then you print out each one, so it prints out the words. But with SympLang, it's actually a lot easier. We can replace 1 with the word 1 and 5 with the word 5. And now if we go ahead and run it, you'll see that it says 1, 2, 3, 4, 5. So now what it does the exact same thing as I described before, but when it sees 1 to 5 written out as words, then it will work with words instead of numbers. So it still knows that this is the number 1, and this is the number 5, but when it goes to print it out or write it out, then it will write it out as words. It just knows that, the digit 1 corresponds with O-N-E, and so on and so forth. So just by changing that one little thing, it'll actually, print out the words. Not terribly useful, but just a cool thing to show how Java, you need to rewrite the whole thing. In SympLang, you really don't. You just have to change your sentence a little bit. Let's try something a little bit more complex. We're going to work with some list manipulation. Over on the Java side, I'm going to use streams because streams are the best that Java can offer. If I compared plain old Java to SympLang, that wouldn't be so fair. So I'm going to compare the best that Java can do to the best that SympLang can do. So what we're going to do is we're going to create a string. We're going to create a list of strings. We'll just call it list. So we're going to create an array list of strings, and this array list is going to contain this is a test. So it's going to contain those 4 words. This is a test. And what it's going to do is we're going to do a couple of things. First, we're going to replace each word with its length. So the word this would become 4, is would become 2, a is 1, and test is 4. So whatever the length of the string is, that will become what it is. Then what we're going to do is we're going to remove all of the values that are greater than 3. So this would be 4, test would be 4, so those would go away. All that's left is and a. Then we're going to write what's left in increasing order. So the order would be 2 and 1. It would write it out as 1 and then 2. And alright, so let's go ahead and try this out. Let's just make sure that I can do this. So first we're going to stream it. Then if we want to turn each word into its length, we're going to do map with string length. So it's going to take each string and then replace it with the length of the string. Then we want to filter them. So we're going to filter, we're going to take in the string, and we're going to say string.length is less than 3, because I believe that would filter out all of the, oh, I see, it's an integer, I'm sorry. So it's going to take I, and it's going to say I is less than 3. So it's going to take the number, and it's going to say if it's less than 3. I believe that means if it's, actually, I think it's going to filter for greater than 3. I think that's what we want. So that should get rid of everything that's greater than 3. If that's wrong, then I'll fix it. Oh, so only if it matches them, so less than 3. I'm sorry, I got a little bit confused. You know how Java can be. Alright, so if it's less than 3, then we want to keep it. Finally, we want to write them. So we're going to say, so first we want to sort them. So it's going to sort them in natural order. We'll try that and see if it does it in the correct order. If not, then we'll fix it. And then finally, we're going to do for each system.out println. So it's going to go through each one and print it out. So let's run this, and it says 1 and 2. So that's exactly what we expected to happen. It does say 1 and 2. Actually, I think that we wanted, let's just make it a little bit better. Let's have it be delimited by a comma. So there will be a comma in between the numbers. So instead of that, we're going to take I, and we're going to system.out.println I with a comma space. And we don't want to do println, we just want to do print. So if we run this again, you'll see it says 1, 2, comma. Again, not great. We do have the extra comma and space on the 2, but I'm not going to spend any more time on this program. Let's see if SympLang can do any better. So let's delete that. And what we're going to do is we're going to write exactly what we just did, the instructions of what to do in English. So we're going to say, starting with a list containing this is a test. So first off, we're telling it to start out with a list. And so it'll say starting with a list, which means it's essentially saying this is a block. So we're going to write everything in here tabbed in. All the instructions are going to be tabbed in. So we're saying that we're starting out with this list, and then we're going to operate on the list inside of this block. And containing, what are the values of it? This is a test. And it knows that they are each their own separate value. So the first thing that we're going to do is we're going to replace each word with its length. It's able to figure out that word is talking about the list. It can infer that. Length, it can figure out that it's the length of the word, and then replace will replace it, can figure that out. So the second thing that it's going to do is remove all values greater than 3. So it can figure out, again, that you're telling it to remove something. When you say all values, it'll go through every single thing in the list. And then this comparison greater than 3, that's just a comparison. It can figure out what you're talking about there. Then finally, we're going to say write the contents of the list in increasing order, delimited by a comma. So now, this will, again, the contents of the list, it'll figure out what's in the list, and it'll write it out. When I say in increasing order, it'll first sort it in increasing order. And I could make that a separate step. I could say sort in increasing order if I wanted to. But you can have compound statements in a line. And then delimited by a comma means it'll, stick a comma after. But it's actually smart about that. It won't stick a comma at the end because, that wouldn't really make sense. So if I hit run, you'll see it gives me 1, 2. No space and no comma at the end. So it's able to do the exact same thing as Java, but it looks like a list of operations, exactly how to do something. Again, written in plain English, very, very simple, and the output is nice and clean. Great. We're almost finished here. Let's just look at one more example. Let's say that we want to have a countdown for some reason. We want to count down the numbers from 10 to 0 and then say launch. I suppose in Java, let's just use thread.sleep for this because I'm lazy. So we're going to say for int I equals 10, I is I is greater than or equal to 0, I minus minus. We're going to print out I, and then we're going to do try, lowercase t, thread.sleep for 1 second. And then we're going to catch the interrupted exception. And we'll just print out the start trace. That's not going to happen, though. And then finally, at the bottom, we'll print out launch. Okay. Alright. So if I run this, it'll say 10, 9, 8, and it's going to run through the whole thing. Now, that's not terrible. It was pretty quick to write, but again, it doesn't really make too much sense in English. And then you have this, ugly try-catch thread.sleep thing. So it would make a lot more sense, to write it in English instead of having to say thread.sleep, if you could just say that it's a countdown, people would know how a countdown works. So this is a demonstration of, let's just delete this. I'm going to show you how to do this exact same thing in SympLang. All you have to do is write countdown from 10 to 0, then say launch. Now this seems like a weird thing for a language. How would it know what a countdown is? So I'm working on a modular system for SympLang where other developers, it's kind of like a library for Java, how you can add extra classes and then people will import your library and use it. I'm working on something similar to that, and the countdown is just a test. So I have it define, countdown and how exactly a countdown works, so that when I run this, I have it automatically included. But eventually it would become a whole modular thing as I work on this more. So when I do this, it can figure out what exactly a countdown is, and then it can figure out 10 from 10 to 0, so it knows where it's going. Then say launch, and the then is sort of like a semicolon separating the two things. It just makes more sense in English. I could put a period there, and then on the next line I could write say launch, but it doesn't really matter. Finally, let's go ahead and run this, and I'm gonna do that. And you'll see it's going 10, 9, 8, and it's going to go through the whole thing, and does indeed work. And you'll see it with 2, 1, 0. Okay, and then it says launch. So that is exactly what we expected it to do. It's just one line. Normally it would be a little bit more complicated, but I've been able to abstract some of that away by defining this countdown word. Okay. All right, we're almost finished. So that's a pretty good comparison between SympLang and Java. Remember, this is a very early version, so there's not too much to show you guys, but that's definitely a good demonstration of how easy SympLang is to use and how it's better than Java, at least in my opinion. Finally, I just want to show you something that's a little bit fun. One of the first things that I accomplished with SympLang is it can tell you a little bit of information about itself. This is kind of when I was testing it initially to see how it would work, how it would parse the data and understand it. So you could just write something like print information about yourself. And if I run this, it will give me some information. So let's go ahead and run this. It says, I am SympLang version 1.0.7 alpha, a next generation programming language based on the way people speak. So some information. Unless I'm just an April Fool's prank. Yes, if you guys couldn't figure this out by now, this is an April Fool's prank. I would be thoroughly impressed with anyone, let alone myself, being able to create a programming language like this. But it was a cool idea that I had, and I wanted to kind of do it. I like April Fools. I did a video last year, and I wanted to do one this year. So for those of you who just spent the last 20 minutes watching this thinking that I've created the next revolution in computing, I apologize, but I hope that you get a good laugh out of this. This is just a little thing that I threw together. In case you're curious, the console just works based on numbers. I hit numbers on the keyboard. So I hit numbers on the keyboard, and then it will just, write out to the console. So that was, of course, a prank. But I hope you guys did enjoy this video. As always, subscribe if you want to see more. Comment with what you want to learn. If you like this video, click the like button, and I'll see you guys soon with some actual coding. Bye for now.